Welcome to The Explainer. Today, we are building a fortress. Not with stone and mortar, nope, we're building it in the cloud. We're going to architect a super secure AWS network from the ground up, piece by piece. So, let's dive right in.
So here's the big question, right? The cloud is this massive public universe. How in the world do you carve out your own private corner, lock the doors, and keep your most important stuff safe? Well, that's exactly what we're here to figure out.
And we're not just going to talk about it in theory. Oh no, we are going to build this thing together. We'll start with the bare foundation and add every single layer step by step until we have a complete, secure fortress. You ready to lay the first brick?
Okay, first things first. Every great building needs a rock-solid foundation. And in AWS, your foundation is your very own private slice of the cloud. This is where it all starts. And that brings us to the VPC, or Virtual Private Cloud. I want you to think of the entire AWS cloud as like a massive ocean. A VPC is you planting a flag and claiming your own private island right in the middle of it. It is totally isolated, and you and only you get to make the rules about what comes and goes.
All right, so we've got our island. Awesome. Now, just like you would with a real city, we need to zone it. You can't just put the nuclear reactor next to the playground, right? We need different areas for different purposes.
We do this with things called subnets. Your public subnet, that's like your island's beachfront property. It's got a direct line to the outside world, which makes it perfect for things like web servers that need to greet visitors. Then you've got the private subnet. This is the secure, inland part of the island, totally cut off from the internet. It's the perfect spot to protect your crown jewels, your databases, and your back-end servers.
And this right here, this is one of the golden rules of cloud architecture. It's so simple, but so powerful. You put your front door, your web servers, out in the public zone. But everything else, especially your treasure, your data, that stays locked away deep inside the private zone.
So, we've got our public and private zones. But how do we actually control the traffic flowing in and out? We can't just leave the doors wide open. We need gates, and more importantly, we need them to be smart.
First up is the Internet Gateway, or IGW. Think of this as the main harbor for our island. It's this big two-way door that you attach to your whole VPC, and it lets traffic flow freely between your public subnet and the open internet. It's absolutely essential if you want users to actually reach your website.
Okay, that makes sense for the public stuff. But wait a minute, what about all those things we hid away in the private subnet? Sometimes your database or your application servers, they need to reach out to the internet to download security patches or updates. How do they do that without, opening a backdoor for attackers to sneak in?
And this is where the NAT Gateway comes in. And honestly, it is a brilliant piece of engineering. Think of it like a specialized submarine dock on your island. It lets your private resources go out on missions to the internet to get what they need, but it strictly forbids anything from the internet from starting a conversation coming back in. It's one way only, which keeps your private zones completely hidden and safe.
Okay, so the foundation is laid, our zones are mapped out, and the gates are in place. Now it is time to post the guards. We need security layers that are going to inspect every single bit of data trying to get in or out.
In AWS, we get two main types of guards, security groups and network ACLs, or NACLs. A security group acts like a personal bodyguard, assigned to each individual server. A network ACL, on the other hand, is like the main perimeter fence around an entire zone. Now, the biggest difference between them is memory. Security groups are stateful. If they let a request in, they remember it, and they automatically let the answer back out. NACLs are stateless. They have the memory of a goldfish. You have to write one rule to let traffic in and a separate rule to let the response back out.
So here's the key takeaway. These two things are designed to work together, like a defense in depth strategy. The network ACL is your big, tough fence around the whole neighborhood. It's your first line of defense. But even if something gets past the fence, each server has its own personal bodyguard, the security group, waiting for one final check. You absolutely want to use both for a truly secure setup.
All right, we've collected all the pieces, we've defined all the parts. Now it's time for the big reveal. Let's put it all together and take a look at the final blueprint of our fortress.
The best way to really see how this all clicks is to follow a single user's request from start to finish. We're going to trace its path as it travels through a totally standard professional setup called a 3-tier web application. Let's follow it all the way from the user's browser to our protected database and back again.
Okay, here we go. A user clicks and their request zips into our VPC through that internet gateway.
It's immediately greeted by a load balancer, which acts like a traffic cop and directs it to a web server in our public zone. That server then turns around and talks to an application server in the first private zone. And finally, to get the actual data, the app server queries the database, which is locked away safely in a second, even more secure private zone. See? Every single piece has its job. It's a perfect system in action.
And that's it. Just like that. The user gets what they wanted, your application is running smoothly for the whole world to see, and most importantly, your critical data was never ever directly exposed to the dangers of the public internet. That, right there, is the power of a well-designed cloud network.
So there you have it. We've laid the foundation, we've built the fortress. You now have the blueprint for creating secure, scalable, and seriously professional cloud infrastructure. The only question left is, what are you going to create with it?